Welcome all, where we'll make statistics simple and easy. So today I want us to learn about curve estimation. Curve estimation is whereby you want to perform a regression analysis, but you don't know which is the best regression analysis that you can perform, or which model that you're going to use. So in this case here, I have hypothetical data or laying of birds. This is a percentage laying, and then this is a FCR, that is feed conversion rate. So we want to see, does feed conversion rate influence laying of birds? So one of the things that we are going to do is go to analyze, and then in regression. So you see all these are regression models that you are supposed to use, but you don't know which specifically that we are going to use. So we go to curve estimation. So when you go to curve estimation, our dependent variable is laying, you put it there, and then our independent variable is the feed conversion rate. So you put there. So the challenge with this is you can only use one independent variable to predict the dependent variable. So in this case here, the main thing that I really want us to have is maybe, let's say, because this was a continuous data, so we can have linear, we can have logarithmic, you can even decide to choose all of them. Let us just choose all of them and see which is the best model for us to have. So the other thing might not even need this, because I'm just interested with the model summary. How is the model performing? And of course, I need the plots here. And I click OK. So once you click OK here, you're going to get a summary here. So this summary here, the first thing you're going to be given is the R square value, the F, the degrees of freedom, the significance, and now the parameters. Those are the parameters, B1, B2, B3. So you can see that all these models can be used to explain the variation in laying percentage. But now the other thing, the good thing with the model summary, you can come back to R square. Remember, R square is the percentage of variation that can be explained. You can see that linear, despite it being significant, it can only account for 21%. You can see something that like logarithmic can only account for 59%, inverse 97%, which is very high, quadratic, cubic. So with all these, it's going to tell you the best model that you can choose is inverse, which has 97% R squared, and also the S model, where it has 0.948. So that is 94% of the variation. So that is the strength that it can be able to tell you, so that when you're going to perform your analysis, you know that the best one that I'm going to use is either inverse regression or S regression. And also here you can see our dotted marks here are the points which have been, and you can see the best one is, one of the best one is this. So this one is let me just try to, so if I put it here and double click it, and to double click, and maybe, and this is inverse, yeah. So you can see the model. See, this is the equation here. So if I try to put the, let me just color that line, and you can see I've colored it maroon. So inverse, so this is the inverse. So you can see inverse had 0.97 R square. So also the other one we can try to see, let us see which one is this. This one. So let me just try this. So just double click it. Let me just click, and then we see which. So you can see this is S. So S, you can see most points are within the inverse, and so you're going to choose the, so S, you can see S. So this is S. So S is 0.948. So you can see also S was really trying, but at one point it was, oh, the most of the points didn't come with it. But you can see how the curve is. The curve is as the way the points were going. So you can see also in this case that, but you will see that inverse recorded most of its points were along the curve. So, and also for S also the points were here, but at this corner points, yes, despite the points having that shape, they were not along the S curve. So that is how to determine your curve on the model that you're going to use to regress your data. Thank you, and remember to subscribe.